So I got my book, and we're going to the back of the book to find Table A, all the way to the back cover, and go back. There's a couple of charts back here, some blank pages for you to not write on. There's a big old chart for something called a chi-square distribution. We'll deal with that second semester. There's a t-distribution, that's second semester. And then on page T2 here and T1, that's the one I was looking for. That is a table of values for percentages. You put in a z-score, like right there, and the chart gives you the area to the left. So let's see, 0 would be in the middle. So let's say that z is -1. Well, here's what I do. I look for -1 over here, and this chart goes 2 decimal places. So if I want to go to -1, there's -1.0, and then you see there's all these across here. This is the second decimal value. So like, for example, this one right here, that would be -1.1, and then look at the top of this column up there, it's a 2. That's -1.12. If I'm 1.12 standard deviations below the mean, -1.12, the percentage of data values that are less than that data value is 0.1314. If this is -1, -1.00 would be 0.1587. And that's how the table works. Now, before I get rid of the book, if I go to the next page, and I put this down here for you, there's where all the positive z-scores are. So that's to the right of the mean, and you notice that these are all over 50%. Because if you're above the mean, then you have 50% of the area here, and then some more to get where you are. So these are all bigger than 50%. Okay, so here we go. Find the value from the table for a z-score of 1.62. So I'm going to bring the book back in here, and 1.62, I would go to 1.6, and then I go over until I hit 1.62. That number is 0.9474. So let me write that in the notes. 0.9474. The interpretation of that value is 94.74% of data values from that distribution are less than a value that is 1.62 standard deviations below the mean, above the mean, just like I've drawn right in there. This shaded part is 94.74% of data values. Okay, find a table, find a value for a z-score of -2.48. Okay, you got your book open. Go ahead and go to the page where you have negative z-scores, and look up down the column, you go to -2.4, find your row, and go across until you get -2.48. You should come up with 0.0066. So look what that means. I'm going to draw a real small normal curve. You don't have to do this if you don't want to. I got 0, I go 1, 2. If I'm all the way at -2.48, there is not a lot of area to the left there. Most of the area, most of the data values are bigger than -2.48 as a z-score. So it should be a real small percentage. The interpretation is 0.66% of the observations from this distribution are less than a value that is -2.48 standard deviations below the mean. Okay? Example, use the table to find the proportion of values that are within 1.5 standard deviations. You guys got to get used to this concept. Within 1.5 standard deviations from the mean goes like this. There's the mean. I go 1.5 standard deviations this way. I also go 1.5 standard deviations that way. And this is the area I'm talking about. Anything that lands in that shaded area is within 1.5 standard deviations of the mean. Whether it's above or below doesn't matter. Within means go both directions and make an interval. So how would we actually look that up? I would look up 1.5 and get a number that's too big, because the table gives you everything to the left. Then I would look up -1.5, and I would subtract them. So here you go. Find the entry for 1.50. So look up 1.50 in the book. I'm seeing it right here. It's 0.9332. And then the entry for -1.50. You got to flip the page in order to do that. So I'm going to flip the page. I'm going to look up -1.50. I'll get 0.0668. Oops, 0.0668. And then, of course, what do? You subtract them. I just misspelled it. That's all right. If I keep spelling it, you'll get it out of context. And so what I get is 0.8664 if I put that in the calculator. So what did I just do? I'm going to draw a picture for you. There's 0. There's my standard deviations on a standard normal curve. It's a 1, 2, 3, -1, -2, -3. And from 1.5 to -1.5, I'm saying it's 86.64% of data values are in that little interval within 1.5 standard deviation of the mean. Find the proportion of observations that are more than a value that is 1.43 standard deviations away. Okay, so go to the chart and look up 1.43. Now, I'm gonna draw that over here. If I look up 0, 1, 2, 3, 1.43 is going to be somewhere around here. Now, when I look that up, that's going to be a lot of area, but that's not what the question's asking. It says more than. I'm actually looking for this blank spot up here. Okay, so then what you're going to do is a 1 minus. The area under the curve is 1, and if you have this much, you just take the full 1, subtract this decimal, and you get the other one. So I look up 1.43, and it ends up being 0.9236. So what I mean by that is 0.9, dang it, misspelled it. 0.9236 is this shaded area, but I want that area. So I go 1 minus 0.9236, and my answer is 0.0764. That is the percent of data, or the proportion of observations that are more than 1.43 standard deviations above the mean. Okay, now here's put a little asterisk here. This is different. Now I want you to find the z-score for the standard normal distribution that serves as the 90th percentile. Okay, I want you to write the word inverse here. I just asked that question backward. I'm giving you the shaded number, 0.90, and I'm asking you for the z-score. So look what I'm asking you to do. Go find a place where 0.90 is the shaded area. Tell me what the z-score is. That's what I'm asking you to do there. So let's go back to the chart here. This is the page with all the negative values. There's no 90% on this. Everything less than 0 is going to be less than 50%. So I got to go to the other page. I'm going to get this in view here for you. And your job, there's 50s up here, there's 90s up here. We're looking for where 90 is. 90s, 90s, 90s. Then there's some 80s, so 89, 89.4, 89.6, 89.8, 89.97, then 90.15. It's right in here. 90% as a shaded area is in between these two numbers. Now what is that? It's 1.2, and I think I would lean towards this one, 1.28. So the answer to that question is that z would equal 1.28. If you have a data value that has a z-score of 1.28, that data value is the 90th percentile. Well, that's a lot on this page. Next page.